fellows, this is MATLABs again. If you missed the previous video on question 3, you can actually download it from the link below. I'll leave a link below that you will actually use to download the video if you missed the previous one, because in the previous video we're actually looking at question 3 of the analytical geometry, grade 11, from a question paper taken from the set by the Department of Education, but today we will actually focus on question 4. Why did I choose question 4 and why did I choose question 3? I chose question 3 because question 3 is actually highlighting to you as a learner to say questions in analytical geometry can sometimes involve quadrilaterals, but in this question we are actually having a triangle. Let's look at the question. You are having a triangle, so it means sometimes the questions that come in analytical geometry, sometimes it will be triangles, sometimes it will be quadrilateral. So you need to acquaint yourself with any type of a question. Okay, so now, like I've indicated in the previous video, to say when you are given a diagram, relax, make sure you're sober, and don't be in hurry cause worry. So let's check the diagram. The first thing that we know is that this is a right angle triangle. You have a right angle triangle which is divided into two other triangles. So it means you are actually having two right angle triangles, if you can see that. Okay, you are actually having GFC as a right angle triangle. You also have NFC as a right angle triangle. Okay, and immediately when you see right angle triangles from grade 9, I presume, you start to think of Pythagoras theorem. Okay, so it means the likelihood is you might use Pythagoras theorem, but at the same time, when you see a right angle triangle, you also think of trigonometric ratios. Okay, so it means you are likely to use trigonometric ratios. Right, another thing that we see is that this angle, this angle which is 104.04 degrees is actually an inclination. Okay, it's an inclination angle of line CN. Can you see that? But at the same time, you can also tell that there is a little triangle somewhere here. Okay, so this angle, the very same angle I'm talking about, 104.04 degrees, is actually the exterior angle of this triangle. And then from the geometry that you learned in grade 8, you remember theorems relating to triangles. Automatically it means this angle, the exterior angle of this triangle that you can see here, is actually equals to the sum of the two opposite interior angles. And the two opposite interior angles are angles that are not adjacent. So it means you look at angles that are not adjacent to 104.04 degrees. Those angles are the ones that are opposite to the exterior angle. Therefore, when you say the exterior is equals to the sum of the two opposite, you are trying to say the exterior is equals to the sum of the two angles that are not adjacent to the exterior angle. Okay. Now, what is it that is given also? You are also given the coordinates of f to be 2 and minus 2. You're also given coordinates of g to be 5 and 2, and c to be 6 and y. I also said you should actually check the vertices that are given to say, are they in the right quadrants? Okay, so you check g is in the first quadrant, both x and y are positive, this is valid. And then you also check f is in the fourth quadrant, x is supposed to be positive, y negative, this is valid. And then we also have c in the fourth quadrant, so c is positive, we are expecting y to be negative. Okay, at the same time, if there can be a question that talks about the coordinates of n, we know very well that the coordinates of n are supposed to be positive because n is in the first quadrant. Okay, so this is our Cartesian plane. You have your x, you have your y, this is your origin. Okay, this is what we see. So everything that is going to be given about the diagram, or the information that we're going to get here, is everything that I've already explained. Okay, so let's check the question. It says, in the diagram, F has coordinates 2 and -2, G has 5 coordinates 5 and 2, and C has 6 and Y. These are vertices of triangle FGC. You see this triangle FGC, which is valid. Okay, you are also given that FG is perpendicular to FC, and then if FG is perpendicular to FC, that is how the right angle triangles are actually formulated. Okay, the right angle FGFC. Okay, so now at the same time you also have N, which is a point on FG. This doesn't need a metric brain. You can see it is on FG, such that the inclination, okay, you are given the inclination of NC, which is what I was talking about earlier, which is 104,04 degrees. Okay, so the inclination of FG, you see the inclination of FG is actually B. Remember, maybe let me explain something. Remember, when somebody talks about an inclination is an angle that is measured anti-clockwise from the x-axis to the terminal ray. Okay, so it means when you are looking at this angle, it is actually measured from the positive x-axis. It goes anti-clockwise to your terminal ray. Your terminal ray in this case, it's or to the arm, to the second arm. Let me not say the terminal ray, to the second arm of that particular angle. Then it is, that becomes your angle of inclination. Angle of inclination is actually an angle of elevation. It is actually measured from the horizontal up. So you cannot measure an inclination from the horizontal down. So you measure it from the x-axis, you go up. So that angle between the positive x-axis, okay, the positive x-axis, it may not be the positive x-axis, but now it is measured from the horizontal, and our horizontal line in a Cartesian plane is the x-axis. So it is measured from the horizontal. It is measured from the x-axis anti-clockwise, okay, to the other arm. Okay, so that is your angle of inclination. Why are we measuring it anti-clockwise? Because angles measured anti-clockwise are considered to be positive. Okay, so inclination angle is positive in this case. You understand? Now, I said, let's look at the first question. Okay, question 4.1. So in question 4.1, it says calculate the gradient. I've indicated that in analytical geometry, you check the selection of the correct formula is the one that will actually help you to get the correct answer. So when it says calculate the gradient, in your mind, you have already underlined, or at the back of your mind, you have already underlined that, you know, it means I'm going to use gradient formula here. So you calculate the gradient of FG. So a question is, how many marks? How much time are we supposed to take on this question? Okay, so this question is actually 2 marks. Very simple. Okay, now before we actually get into the solution of the problem, let's check the significant aspects of the question. Okay, let's highlight the key areas of this question. Okay, like for an example, you look at C with coordinates 6 and Y. We are expecting to have a question that would say we must determine the value of Y. And the value of Y that we get here, it will actually help us know the coordinates of C. And then when we know the coordinates of C, then it means they will actually help us to answer a particular question thereof. Understand? That is the first thing. Right. Secondly, something that is important is the inclination. You know, we must remember that the inclination is given in this case. Okay, it's given, and we must remember that this is the inclination of this line, because we are actually having many lines here. Okay, we have an inclination of NC, we also have inclination of FG. Okay, right. Another thing that is given is the inclination of FG, which is B. So these three things, which I have actually highlighted with the green line, blue and red, we will timelessly refer to them when we answer our question. Okay. Now, how do we solve this one? The first thing that we're supposed to do is to label. I've indicated to say when you solve analytical geometry in grade 11 or in grade 10 or in grade 12, because I've indicated that mathematical content and mathematical questions do not exist in isolation. It means whatever you do in grade 10, then we will just help you understand in grade 11, and whatever you do in grade 11 will help you understand in grade 12. And basically, the analytical geometry that you do in grade 11 is what you will actually find in grade 12. Believe you me, more than 75% of the content that you do in grade 11 is what you find in grade 12. So if it happens that you pass your grade 11 well, and let's say maybe next year when you are doing grade 12, you happen not to go to school, and at the end of the year they give you a final examination question paper of grade 12 and they say, right, you will get a level 7 or a level 6 without attending, because everything that you do now is what you will do in grade 12. Okay, now let's check it. I said there are 5 steps that you do. Firstly, you label your coordinates x1, y1, x2, y2. After labeling, what do? You choose the correct formula. After choosing the correct formula, the third step will be you substitute. After substituting into the correct formula, you play your maths. You use your calculator, then from there you get your answer, which will be the final stage, number 5. Okay, let's do the same thing now. Okay, let's label. Let's take f, the coordinates of f to be x1 and y1, and the coordinates of g to be x2 and y2. Okay, very simple. x1, y1, x2, y2. Now, let's write down the formula. The formula would be, remember, small letter m is for the gradient. Gradient of fg is equals to changing y divided by changing x, which is y2 minus y1 divided by x2 minus x1. Then from here, you're done. Substitute accordingly. Okay, your y2 is 2, your y1 is minus 2, x2 is 5, and then x1 is 2. Okay, then remember, negative multiplied by negative is positive, then 2 plus 2 is 4, and then 5 minus 2 is 3. Okay, so it means your final answer will be 4 divided by 3. Remember, this is the gradient of FG. The gradient of FG. Before you even continue, you can just check. Okay, FG, it's a forward slash. It is slanting to the right. The gradient is supposed to be positive. Okay, the gradients that are supposed to be negative, that we expect to be negative, will be the gradient of NC, GC, and FC. Okay, but the gradient of FG, the gradient of actually FG alone, is the one that is supposed to be positive. Okay, now we can actually mark our question, the 2 marks. How do we actually get the 2 marks? You'll actually get a mark for correct substitution. Remember, substituting into the correct formula. Okay, and then you also get a mark for the final answer. That's it. How hard is that? Very simple, ladies and gentlemen. Okay, now let's move on to the next question, and that is how you get your 2 marks. Okay, that is how you get your 2 marks. That is why I'm circling it in blue. Okay, so now, because it's 2 marks, you're not supposed to spend more than 2 minutes on this question. Okay, remember, label, number 1, number 2, write the formula, correct formula, number 3, substitute correctly, use your calculator here, play your maths, and then from there you find the answer. Okay, let's look at 4.2. What are we supposed to do? We are supposed to calculate the value of y. People, that is why I've indicated here to say this is significant. We were expecting something of this nature, but remember, we got the gradient to be 4 divided by 3, okay, in the previous question. It's supposed to help us in 4.2, you see, because there is a reason why we were supposed to determine the gradient of fg first before we are asked the question to calculate the value of y. Okay, so how many marks is this question? This one is actually 3, so it weighs more than the previous one. Okay, now let's check. What are we supposed to do now? We calculate the value of y. But what we know is that, remember, we are using properties of perpendicular lines. What we know is that the gradient of fg or gf multiplied by the gradient of fc, they're supposed to give us minus, correct? They're supposed to give us -1 because these lines are perpendicular. The product of the gradients of perpendicular lines will always give you -1. And then when you know the gradient of one line, to determine the gradient of the other one is very simple, because you just take the reciprocal of the first gradient with the opposite sign. So it means if the gradient of fg is positive, automatically the gradient of fc is going to be negative, and the gradient of fc is going to be the reciprocal of the gradient of fg with the opposite sign. Why? Because a number multiplied by its reciprocal will always give you 1. So in this case, it's supposed to be minus. That is why it is a reciprocal, but with the opposite sign. If it is positive, it must be negative. If it is negative, it must be positive. Okay. Now, what are we supposed to do? Let's label the coordinates of f to be x1 and y1 again. But now we are no longer focusing on fg, we are actually looking at fc. Okay, so now let's also label c to be x2 and y2. Why? Because we would actually say the gradient, we will write the gradient formula for this one. Gradient of fc must be equals to what? The reciprocal of the gradient of fg with the opposite sign. Okay, and remember, you calculated the gradient of fg in the previous question, in question 4.1. Okay, now let's write down our formula. That is the first step. Okay, remember, we are saying the gradient of fc. How do you get the gradient of fc? You will use the formula of y2 minus y1 divided by x2 minus x1. This is supposed to be equals to what? Reciprocal. Remember, the gradient of fg was 4 divided by 3. Reciprocal is simple, ladies and gentlemen. It means the numerator must become the denominator and the denominator must become the numerator. So the numerator was 4, the denominator was 3. Now the numerator will be 3, the denominator will be 4. But remember, it must be with the opposite sign. So the gradient of fg was positive, then the gradient of fc must be negative, but it must be the reciprocal of the gradient of fg. Okay, now we can actually substitute. Okay, our y2 is actually our y, the one that we want. Y1 is -2, blah 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 blah. Okay, now you substitute there, so you actually have y2, which is y, minus, remember we have minus here, but y1 is -2, so negative multiplied by negative will give you +2. Okay, then x2 is 6, and then minus x1, which is 2. This is equals to this. Now 6 minus 2 is 4. Then you can actually cross multiply. 6 minus 2 is 4. 4 multiplied by -3 is -12. -12 divided by 4, it's -3. You can play your maths there. Okay, so it means we actually have y plus 2. Okay, how did you get the 12? It's 4 minus 2. Get a 6 minus 2, it's 4. 4 times 3, then you have your 12 here. Okay, so -12 divided by 4, that will give you -3, and then you take 2 to the other side, then your y is equals to -3 minus 2. Ladies and gentlemen, this is a simple arithmetic. So in simple terms, remember, our y is expected to be negative, and -3 minus 2 will actually give us -5, which is mathematically accepted and valid. Okay, so it means your y will be equals to minus 5. As a result, it means the coordinates of C will be 6 and minus 5. Okay. Now, how do we mark it? You'll actually mark it for equating the two. Okay. In simple terms, you are actually getting a mark for writing the gradient of FC to be the reciprocal with the opposite sign. Okay. Then from there you substitute. Okay. You get a mark for substitution. Then from there you will play your maths here, which is simple arithmetic. We can't give you anything here until you find your final solution here. Automatically, if you know your maths well, okay, if you practiced well, from here you can directly come here. Okay, so it means your final answer will be minus 5. I do not see any problem with this. Very, very simple. Okay. So ladies and gentlemen, don't forget to subscribe, and at the same time leave your comments, and so that I can upload relevant videos for you. Okay, give me comments, recommendations, and areas of improvement, everything, things like that. The main intention is to help one another so that you pass your mathematics well. Okay. With that being said, let me not waste any without wasting any time. Let's move on to the third question, which will be 4.3. But now this is how you get your 3 marks. Now 4.3, it says calculate the size of theta. Now this might be head cracking if you do not remember the theorems that you did in grade 8 and 9. Okay, here is theta. If this is theta, we know that theta plus beta should be equals to the exterior angle. Automatically, it means theta will be equals to 104.04 degrees minus beta. So what is this telling us? This is telling us that if we can actually find the value of beta, then we know the value of, because at the present moment we have two unknowns. We don't know theta, we don't know beta. Okay, so if you don't know beta and then you don't know theta, if you have two unknowns, it means you need two equations. And then if you have two equations, it means you must solve them simultaneously. We don't want to solve anything simultaneously. What we want to do is we want to have a one variable equation. We want to have a theta variable equation. Theta variable equation. Right. Now, the question is it possible to determine beta? Yes, because I said this is significant. We are given that beta is the inclination of FG. And remember, every time when you hear the word inclination, then you remember the inclination equation. Tan theta is equals to the gradient of the line that is forming the inclination. Okay. So it means in this case, tan theta is supposed to be equals to what? It's supposed to be equals to, tan beta. Tan beta is supposed to be equals to the gradient of the line that is forming beta with the x-axis. And that particular line is FG. And remember, FG is the first question. We know the gradient of FG. Okay? So now, what are we going to do now? Just okay, that is before I even continue. This is 3 marks. Okay, we don't have to spend more than 3 minutes on this question. Okay, now you write down the formula. Tan inclination angle is equals to the gradient of the line that is forming that inclination, and the line that is forming the inclination is FG. Okay, and then we know this gradient to be 4 divided by 3. Very simple. Okay, but now it means we are actually having tan beta, which is equals to 4 divided by 3. But now, a question is, 4 divided by 3 is positive. So we are going to, if we need the value of beta, we are going to check. We're going to check in which quadrant or quadrants is tan of an angle positive. And then when you check your Cartesian plane, okay, using the cast method, all students take coffee in the morning, right? You remember that one, you did that in grade 10. Okay, now tan of an angle is positive in the first quadrant and the third quadrant. And then if you check here, this angle 104,04 is between 90 degrees and 180. So this one, it is obtuse, but you check beta. Beta is an acute angle, therefore it means it's an angle in the first quadrant. Okay, so it means in this case our reference angle is going to be our angle. Okay, then what do? Use your calculator, tan inverse of 4 divided by 3, and then that will actually give you 53,13 degrees. We will normally round off our answers to to 2 decimal places unless stated otherwise. Okay, so even in your instructions on the question paper, it will be written that round off your answers to 2 decimal places unless the examiner indicates that round it off to 3 decimal digits or 1 decimal place, just like that. Okay, so now it means our beta is equals to 53,13 degrees, which is an acute angle. It's an angle between 0 degrees and 90 degrees. It's valid. Now that we have beta and we also have the exterior angle, then we can determine beta. Okay, since theta plus beta is equals to this 104,04 degrees, it means theta is equals to what? 104 degrees minus beta. Okay, but now you must put your reason in brackets, okay, to say the exterior angle of triangle. The exterior angle of a triangle, what is happening, is equals to the sum of the 2 opposite interior. As a result, it means theta is also an acute angle, is equals to 104,04 degrees minus 53,1 degrees, which is equals to 50,91 degrees. Okay, never say 50,91 degrees. It's wrong. It's wrong. Any number that comes after the comma, you read it raw as it is, because this 9 is not a 10, it's a tenth. Okay, so you can't say 91. It's 50,91 degrees. Okay, now let's mark it. I actually have a mark for the equation with the correct substitution of the gradient that is forming the inclination angle. Okay, every time when the question says inclination, you must remember it is tan of the inclination is equals to the gradient of the line forming that inclination. Okay, right, from there you also get the value of beta. Okay, and then for this one, theta is equals to 104,04 degrees minus 53,13 exterior. The triangle that I'm talking about is the one that I shaded here. Okay, this is the triangle. If you have a triangle and you decide to extend one side, any side, even if you can extend this one, or then an exterior angle is formed. So in this case, 104,04 degrees is the exterior angle of this triangle with this side that was proluded, or this side which was extended. Okay, right, and this is 3 marks. Then from there you'll also get a mark for the final answer. Okay, very simple. I hope you understand. Let's take the last question, because this is a 12 marks kind of a question. Okay, and 12 marks is a lot, ladies and gentlemen. You know how much how many percent is of the examination paper is 12 marks? It is actually 8% of the question paper. Okay, so it's a lot. It's a lot. You You can actually forfeit a level because of 8%. 8% is 12 marks, okay? Because you'll be writing out of 150. Let's look at the last question, okay? That is how you get your 3 marks, okay? Formula, the value of B, and then using the formula that you learn, I mean the theorem that you learned in the lower grade, and then from there getting theta, okay? And question 4.4, it says calculate the length of NC. The length of NC. Immediately when you see the word length, you remember this is the distance, okay? Distance between these 2 points, okay? Distance between N and C, okay? How many marks? You have 4 marks. So it means they are getting tougher and tougher as it goes on, okay? What is it that we're supposed to remember? We need to remember that we know the value of, we know the coordinates of C now, okay? We know the coordinates of C. So we'll label it and say, okay, the coordinates of F is x1 and y1, and then the coordinates of C is x2 and y2, okay? Right, you write it down and say, okay, what is it that we want now? We want to determine the distance, okay? We want to know the length of FC, okay? We want to know the length of FC, okay? Now, you write down the distance formula here, okay? You substitute accordingly, which will be x2 minus x. I said when you see there are keywords, the keywords will help you to say which formulas are you going to use, which formula are you going to use in your answer, okay? Now, you substitute accordingly, okay? And then from there you actually have what? X2 is 6, x1 is 2, okay, and then y2 is minus 5, minus into, then you play your maths here. Just use your calculator. You can just punch it raw as it is in your calculator. Then it will give you the value of C. You can simplify it there. 6 minus 4 is 6 minus 2 is 4, 4 squared is 16, minus 5 plus 2 is 3, 3 squared is 9, okay, and then 16 plus 9 is 25, and square root of 25 is 5, okay? And then remember, we now know the coordinates of C, okay? It is 6 and minus 5. That is why we are using them here, because this value, the value that we got here, minus 5, is the value we calculated it in the previous question, okay? So it means the distance from F to C or from C to F is actually 5 units, okay? Now from there, what are we going to do? Why do we want this? Let me take it back. Why do we want to determine the length of FC? Because I told you very well that when you see a right angle triangle, automatically NC is the hypotenuse of this right angle triangle. I said you think of Pythagoras, but you can only use Pythagoras if you know 2 sides and you need the 3rd side. So in this case, we can determine FC, but we don't know the length of NF. And we also don't know the length of NC. Therefore, we cannot use Pythagoras. But instead, we can use trigonometric ratios. With trigonometric ratios, it means if we know one angle and one side, we can determine the other side. Or if we know 2 sides and then we need one angle, we can determine that particular angle. Okay. So in this triangle, NFC, what is it that we see? We have already calculated theta in 4.3. That is the reason why we're calculating theta, because the answer that we get in 4.3 must help us answer question 4.4. okay, so you look at theta and then we think of SOHCAHTOA to say, okay, if theta is our reference angle in triangle NFC, okay, which sides do we know? We now know FC, and what is the relationship between angle theta and FC? Correct. This side is opposite to this, okay? That is the relationship that they have, Okay, and then now, what is it? What is the special name given to NC in triangle NFC? Is the hypotenuse. Therefore, it means we're talking about the opposite and the hypotenuse. Okay, so and the trigonometric ratio that deals with opposite and hypotenuse is sine. As a result, it means sine theta must be equals to the opposite side divided by the hypotenuse side of this triangle NFC. So that is why we have sine theta is equals to FC divided by NC. Remember, we know FC. Okay, we also know theta. Then you can substitute. Okay, right, it means sine 50,91 degrees is equals to 5 divided by NC. Then from there you cross multiply, and then your NC is equals to 5 divided by sine 50,91 degrees. You play your maths there, use your calculator. Okay, just punch it raw as it is. Okay, 5 divided by sine 50,91 degrees. Then it means NC is equals to 6,44 units. How hard is that? Very simple. You use trigonometric ratios. Okay. Now we can actually mark it. You will actually get a mark for substituting into the correct formula. Okay, the distance formula. You also get a mark for the value of FC, because you can't determine NC unless you know FC or NF. And then there is no way in which you can calculate NF. You don't know the coordinates of N. So the only side that can actually help us is FC, because we know both coordinates, you know. Right. Then from there, we'll actually, you'll also get a mark for the trigonometric ratio, being able to choose the correct trig function, which is sine, and substituting correctly the values. Okay, substituting your FC and your angle. Okay, right, from there you play your maths, and then you find the final solution, which is NC. How hard is that? Very simple, ladies and gentlemen. This will mark the end of this question. Okay, so it means in this question paper you actually have these two questions as testing analytical geometry skills. Okay, remember to subscribe, remember to hit the notification button so that you can actually be notified of other videos that I'm going to upload, and please share with other people, and leave your comments below. For those who didn't, actually, if you missed the previous video on question 3, the one that deals with quadrilaterals, please find the link below. I will leave a link below for you, and then you just click the link and download the video. Okay, so this question was actually a question out of 12 marks. If you don't understand that 12 marks is a lot, look at it. This is a lot of marks. Total marks is equals to 12. Goodbye for now, until we meet again in the next video. Thank you very much.